AWS Elastic Services are at the core of what makes AWS so unique. And in fact, the definition cloud native, or this term that you hear a lot, it really means that you're able to take advantage of this elasticity of the cloud. So let's go through and look at some of the unique things that you can get from using cloud computing. One of the ones is really getting into load balancing, right? So what is in fact a load balancer, and when would you in fact want to use that load balancer? So let's go through here and talk about some of those terms. So to start with, a load balancer gives you the ability to act as a traffic cop. And so what this does is it allows you to decide when to send something to one machine versus another. It automatically distributes incoming traffic across multiple machines. So in this case, you could see that this load balancer may have several different machines that it could send traffic to, but you could look at a health metric, and the health metric could be, let's say, CPU load. Let's say that this machine has 75% load, this one has 99% load, and then this one has 33% load. Well, the one to send the next request to the website would be this node, because this has the lowest traffic. And so this is a very common pattern, and allows you to equally distribute things without using some kind of a gimmick to load balance, like randomly assigning things. You can truly look at the metrics and then assign the traffic. So this is really the essence of cloud computing and cloud native computing. So what about the different kinds of load balancing that you can do on the AWS platform? So AWS ELB, or Elastic Load Balancer, offers three kinds of load balancers. There's a application load balancer, there's a network load balancer, and there's a classic load balancer. So in terms of the application load balancer, that really is something that functions at an application level. And so it really supports things like WebSockets, or also it supports HTTP. So another one to be aware of, though, is network load balancer. And this is really at the TCP level. And TCP is a transmission control protocol, and it's a way of handling, let's say, millions of requests per second while maintaining very low latency. It's a very specific network algorithm. The classic load balancer is really a basic load balancer that allows you to send traffic to different EC2 instances, and it operates at both a request and a connection level. And the idea is that you, depending on what kind of application you're building, you pick between one of these load balancers. So let's talk about some use cases of the Elastic Load Balancer. There's a lot of different reasons to use a load balancer. One of them is that you want to access everything from a single point. And so this is a very compelling use case, right? So you have a website, you want it to appear like it's one machine, but it's actually potentially thousands of machines. Also, you may want to decouple your application logic, and so you can build different tiers. Also, you want to be able to provide a HA environment, or a highly available and FT, or fault tolerant environment. And also, maybe a final reason here is that you want to have this ability to scale up and scale down. And that's what the load balancer does, is it sits in front and it can scale up and scale down. And this is decoupling that workflow. So what does a use case for the classic load balancer look like in this scenario? So you would access things from a single point. That's one point. You also would decouple your application, and you also would have HA, highly available instances, and also fault tolerance, FT, built in. And this is really the classic use case of how the classic load balancers were used on the AWS platform. Now, in terms of application load balancer, some of the features of that are that it has both path-based routing and also host-based routing. It also gives you the ability to have dynamic ports, so you can open up different ports depending on what it is you're doing. You can have deletion protection, request tracking, and you also have enhanced metrics. So that's one of the things that is lacking on the classic, was typically this ability to look at the metrics that are at an enhanced level, and also the access logs, so you can look at exactly what's happening and when it's making those decisions. Now, some other things about the application load balancer is that it's a great way to have a tiered architecture that is maybe a middleware architecture. And another thing that you could do with a application load balancer is you could configure health checks and create target groups depending on what kind of application you're building. So what about a network load balancer? So a network load balancer is a way of optimizing sudden and volatile traffic patterns while using a single static address, an IP address. So you could handle, for example, millions of requests per second, in fact, which would be just a tremendous amount of traffic, but you could also have very low latency. And so this is a very compelling use case for using a network-based load balancer. And this could be really in an extreme scenario like a high-performance game server. Like if you were going to build something like Fortnite or one of those really high-end games, this would be a way that you could actually monitor that and scale it up when you needed it. So load balancers in general are a way of automatically distributing incoming traffic, and ELB again offers the application load balancer, the network load balancer, and the classic load balancer, and there's several ways to actually monitor it. So let's dive into another topic here, which is CloudWatch. So CloudWatch actually is integrated in many different services, and it's almost confusing in a way because it does so many different things. But in a nutshell, the three main things that the CloudWatch system does is allows you to track your resources, allows you to collect and monitor your log files. And so you can search them with CloudWatch logs, and you also can have notifications. And so you can set alarms that say, let's say this CPU is at the threshold that I was looking for, and I'm going to go and do some kind of action based on it. And also the CloudWatch metrics can be tuned where you can collect it at a minute interval, a 5-minute interval, or let's say a 1-hour interval. And all of these different metrics can be configured, and these events can get sent to do different types of actions. So let's look into some use cases for CloudWatch. Well, one of the use cases would be, let's say you're spinning up an EC2 server and you want to set up an alarm where if the CPU is over, let's say 60% for 5 minutes, you would want to go through and maybe spin up a second EC2 server. That would be a classic case. Or maybe the RDS server, if you have, let's say, over 15 requests that happen simultaneously for about 1 minute, you would go through and maybe you would provision a higher amount of CPU associated with that RDS instance. Or maybe with ELB, you could set an alarm where if the number of hosts that are healthy decreases below, let's say 10, then you need to spin up another, let's say 5 EC2 instances. So these are all health-based metrics, and that's a typical one. Another thing you can do as well is you can set up actions like you can stop a service, you can terminate, you can scale up, and you can scale down based on these actions. So really it's a trigger where you can automate completely and set up a dynamic infrastructure. So that's one of the really powerful things about CloudWatch. All right, let's talk about some this generic concept of scaling and auto scaling in AWS and why it's so important. So scaling is a way of providing a simple and powerful user interface that lets you build scaling plans for things like EC2 or Dynamo or Aurora. And you can do it with most of the AWS services that you care about. And a couple ways to think about it is that you can either scale out or you can scale in, and there's advantages to both. Let's say you get a lot of traffic to your website. You may want to quickly scale out here so that you're able to get, let's say another 6 instances spun up within 5 minutes. But then once that traffic goes down, you don't want to be spending for all these servers that you've spun up. You want to scale back in again. So not only do you want to be able to expand, but you also want to contract. And a lot of the ways you do that, again, was with these CloudWatch metrics and scaling groups, so that you look at the health metrics and you can dynamically configure your environment. So a lot of these concepts really get into this concept of capacity management. And one way to look at this capacity management issue is if, let's say, like this is a graph, Monday, Tuesday, Wednesday, Thursday, Friday, and your traffic typically goes like this. You don't want to just spin up servers and always have 100 servers running. That's going to be very expensive. Instead, what you want to do is you want to be able to have, let's say, 100 servers get spun up quickly. And then at this load, let's say this is 5 servers, you want to be able to spin back down again when you don't need that much traffic. And this is actually a very similar situation that I had when I was working in the Bay Area. I was working in a sports social network, and we actually got millions of page views in an hour. And we actually had some problems with the way we configured things, and we had to manually scale up and scale down. And that obviously is not the correct way to use the AWS cloud. The correct way is that you automatically scale and add instances based on a metric like CPU load. And then when that CPU load goes down, you actually scale in and you get those instances to go back down. So really in action, as I just described here, what happens is you want to set an alarm for your system that looks at a health check metric. It could be CPU, it could be latency, like how long is it taking. It could be the health of the machine. It could be some kind of custom metric potentially that you're looking at, like maybe the number of users on a specific database. Anything that's a health-based metric here that you've decided, or a custom health-based metric, can trigger an alarm, which then triggers a scaling operation. And that scaling operation can then go through and scale up instances like this. And then when the metric goes back down again, it can then scale it back down again. So this is one of the most important aspects of cloud computing. And it's really easy to look at it and think it's not important. But in fact, it's the heart and soul of what cloud computing is the ability to not just spin up resources and spend money, but also to accurately design your system so that it's flexible, elastic, fault tolerant, and able to actually handle in a very cost-effective way traffic that comes your way. And this is really what it is like to be a cloud expert or a cloud architect, is you know how to do this and you can put those actions in place.